So looking at this first problem, we see that this looks very much like a problem that we did yesterday, except that we have 2 to the negative 4. Now, when we want to do expansion, remember when we expand or deal with negative exponents, that means we're dealing with the reciprocal. And so one of the ways that we talked about dealing with this was to just take whatever that negative exponent was and go ahead and flip it over the fraction bar. So what I'm actually going to do here before I expand, and if we want to use expansion, we need all positive exponents. We're going to change this to a positive exponent by flipping it over the fraction bar. So I've crossed it out and moved it to the bottom. So now when I expand this, I'm expanding 2 to the third over 2 to the fourth. So basically we created a division problem here. I'm going to create some space over here. So we have 2 to the third, we're expanding on top, 2 times 2 times 2. And on the bottom, after that move, we have 2 to the fourth, 2 times 2 times 2 times 2. We want to go ahead and do our simplification by canceling out. Cancel, 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 cancel. And I've got 1, 2 left over. This is where we have to be very careful to make sure that we're attentive to where that 2 is left over. Where is that 2 left over? Top or bottom?
Bottom.
Bottom. So that means the 2 should be left over on the bottom. Now, if there's nothing left over on top, what does that mean should go on top? Show me with your finger. Hint, finger. Good. 1/2. Okay? So I've left some space over here because in a second we're going to do this by rule. And we're going to check that it's going to be the same thing. But for now, I just want you to leave that space. I want to go ahead and do the next problem. It says x to the negative 1 times x to the third. Once again, we can't do expansion if we have negative exponents. So if we have negative exponents and we want to do expansion, we have to do that step first of flipping the negative exponent over the fraction bar. So I have negative exponent. I want to flip over the fraction bar. It becomes now positive x to the 1. So expand out what we have now. X times x times x over x. Get our cancellation going. Now I've got 2 x's left over, just making sure we're attentive to where those are left over. Are they left over on the top or on the bottom?
Top.
Are they left over on the top or on the bottom?
Top.
They're left over on the top. So that would make it x squared over 2. Now if there's nothing left over on the bottom, what belongs there?
Nothing.
Nothing, because it's like it would be over 1, but just like we know 6 over 1 is the same thing as 6, or 4 over 1 is the same thing as 4, we know x squared over 1 is just x squared. Judea.
So if one is a negative, they goes to the bottom.
Anytime we have a negative exponent, before we can use expanded form, we have to flip that negative over the fraction bar to make it positive. So if it's on the top, it indeed moves to the bottom.
But how did that get to the? How did that get to the?
So now, looking at the next one, we have y to the negative 5th and y to the negative 2nd. These both need to be flipped. So I'm going to add my fraction bar. I'm going to flip the y to the negative 5th to the bottom to make it y to the positive 5th. I'm going to flip y to the negative 2 to the bottom to make it y to the positive 2. Now when I'm ready to do my expansion, what do I have on top?
Nothing.
Nothing, which means I should put a
1.
When I expand the y to the 5th, that's y times y times y times y times y, and y to the 2nd,
Times y times
y times y. So all of my leftovers are all on the bottom. And I have 1, 2, 3, 4, 5, 6, 7 leftover y's, so that's y to the 7th is left over on the bottom. Since there's nothing left over on top, I put a 1 on top. Questions about that? All right.
I got a question.
Yes.
Never mind.
Okay. Now, looking back at this we remember our rule from yesterday. When we were doing multiplications, what was our rule that we used when we had multiplications yesterday, Emmanuel?
We add the exponents and the base.
Add the exponents, and what happens with the base? Base stays the same. All right. Add the exponents, base stays the same.
Wait, how does the base stay the same?
So looking at all of these had a base of 2, so that meant we had a 2 in the answer. All these had an x, so we ended up with our x in the answer. All these had a y is in the answer. Base always stays the same. So now if we're going to do these same problems by rule, this is just going to be look a little bit different because there are negative numbers involved, but the rule still is the same. I have 2 to the third times 2 to the negative fourth. So my rule is to add the exponents. 2 to the 3 plus negative 4. Now I have to just be exceptionally careful. Because when we're adding positive and negative numbers, we've got to be thinking about like signs add and different signs subtract. In this particular case, this problem is opposite signs subtract.
Different signs subtract, not opposite.
So I'm going to get 2 to the
Negative
1, take the sign of the larger number, that's negative.
What now?
Now, is 2 to the negative 1 the same thing as 1 over 2?
No.
Everybody, kip yes or kip no. Is 2 to the negative 1 the same thing as 1 over 2? Lots of no's here. Sonny, why are you saying yes if everybody else is saying no?
Because he's smart.
Absolutely. So Sonny is saying that this is not a simplified answer, so I would take this 2 to the negative 1. I'd create a fraction bar and flip it over the fraction bar. I'd get 2 to the 1 on the bottom. 2 to the 1 is just 2 with a 1 on top. So it's the same answer, 1/2. Just realize that when you do these different types of problems, on these problems you're going to have if you do the expanded form, you have to do some flipping on the front side at the beginning, and sometimes if you use the rule, you have to do the flipping at the end. Okay? So just keep that in mind when you're choosing which way you want to do the problem. So if I'm going to do this one using the rule, it would be, since it's multiplication, x to the negative 1 plus 3. Different sign subtract would be 2, take the sign of a larger number, positive 2. I get x squared. Same answer.
So this is what we're going to be doing the whole time.
If I wanted to do this next one using the rule, I had to have y to the negative 5 plus negative 2, because negative 5 plus negative 2. That would give me y to the, like signs add, 7, take the sign of a larger number, negative 7, y to the negative 7. But wait, is y to the negative 7 the same thing as 1 over y to the 7? Yes, indeed it is. Because if we wanted to simplify this y to the negative 7, this is where we have to take that extra step. A negative exponent is not simplified. So we'd flip it over the fraction bar. We'd get y to the 7 on the bottom. Nothing would be left on top, so we'd put the 1 on top. We'd get 1 over y to the 7. It's the same answer, either way. Okay? Questions? All right. So looking at these two at the bottom that we would want to do only with the rule. So with these particular problems, this would seem like too much expansion for me to really want to do it with expansion. So instead, I'm going to do it by the rule. X to the 13, since it's multiplication, plus negative 8. think to myself, like signs add or different signs subtract. Different signs subtract. Take the sign of the larger number, that's positive. So I have x to the fifth. Is x to the fifth a simplified answer? Absolutely. The next one, if I want to do it by rule, again, it's a multiplication, same basis, so the base stays the same.
We have to multiply?
I'm going to add the exponents, negative 23 plus 15. Again, you're writing it in the line because that is what really keeps a lot of you from making mistakes with these additions that have positive and negative numbers. This one's different sign subtract. Gives me 4 to the 8. Take the sign of the larger number, and I get 4 to the
8.
negative 8.
So that's 1 over 4.
Is this a simplified answer?
Nobody.
No, can't have a negative exponent. So what do I need to do?
Change it. 1 over
Jalen.
4, 8.
We could put the negatives down under, and then it will be 1 over 4 positive 8x squared.
Perfect. 1 over 4 to the 8. So I flip it over the fraction bar and make it 1 over 4 to the 8. All right. Coming over to the other side. Now these are division problems. These are ones that if we were using the rule, according to our rule, we would be subtracting. So we're going to do the rule on the other side here in a second. But we're going to start with just the expansion. Now, again, before we do expansion, if we have a negative exponent, what do we need to do with it? Before we do expansion. Iron. Flip it over the fraction bar. So I'm going to take this 5 to the negative fifth, and I'm going to move it to the bottom, make it 5 to the positive fifth. When I'm doing the expanded form on this one, I see there's nothing left on top. So I'm just going to put a 1. I'm going to expand 5 to the fifth on the bottom. 5 times 5 times 5 times 5 times 5. And the 5 squared, which is also on the bottom. 5 times 5.
It's 1 and 5.
1 over 5 to the 7th. Now, remembering our rule for when we divide, what was our rule for dividing? When we divide exponents with common bases. Sage? Subtract the exponents.
What? No, it isn't. It says right here. We have to cancel out the number of this that match.
Base stays the same.
I know my question. What is it? What?
So if we wanted to have done this one by rule, we would have set it up 5 to the negative 5. 5 to the negative 5 minus 2. Now, if we want to do negative 5 minus 2, what are we going to have to do first? Judea. Yep, so leave chain switch. That would give me negative 5 plus negative 2.
Negative 7.
Would be 5 to the negative 7. Then if we wanted to finish this answer, because it's not simplified, I'd have to flip this over the fraction bar to make it 5 to the positive 7. That's where our 1 over 5 to the 7th comes from. So again, we see if we use the rule here, we have to do some flipping at the end, whereas if we did the expansion, we had to do some flipping at the beginning.
The beginning. Right.
All right? So looking at the next one. X to the 7th over x to the negative 2. What do I need to do before I expand this? Raven, what do I need to do before I expand this? Yeah, so this one's on the bottom, so when I flip it, it moves to the top. And that actually leaves nothing on the bottom. So I have x to the 7th, x times 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 x squared, x times x. If I count it out, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. X to the 9th, and if there's just a 1 on the bottom, 6 over 1, same thing as 6. X to the 9 over 1, same thing as x to the 9. If I wanted to do this one by rule, I would have had x to the 7 minus negative 2.
You just add those because you got a peaceful plus sign.
So here we need to leave change switch, which gives us a peaceful plus sign. X to the 7 plus 2 would be x to the 9. Okay? Questions so far?
Whoa. Watch your mouth.
All right, now we get down to this last one. Z to the negative 6 over z to the negative 3. I have two negative exponents. What do I need to do before I expand them? Maria? Flip them. So we got to flip them both. The z to the negative 6 becomes z to the positive 6 on the bottom. And the z to the negative 3 becomes z to the positive 3 on the top. So when I do the expansion here, I have z to the third, z times z times z, over z to the sixth is now on the bottom, z times z times z times z times z times z. One z cancels out with z, one z cancels out with z, one z cancels out with z.
3 Z's.
I've got 3 z's left over.
Z to the
They are left over on the
third.
bottom.
So that's 1,
And if there's nothing left on top, that means that we should put a
1.
1.
Yeah, bruh.
If we were to have done this one by rule, z to the negative 6 minus negative 3. Leave change switch gives me a peaceful plus sign. Negative 6 plus 3. Different sign subtract. Viviana.
You get C negative 3, which you flip and you get 1 over C3.
Alright, so we get z to the negative 3. So we flip that over the fraction bar. 1 over z to the third. Again, same answer here. Questions? All right. So now we've got two problems down here that I want us to do by rule. These are ones where it would be unreasonable for us to do expansion. So I have 6 to the 26th. Since it's division, our rule is to subtract minus negative 13. Leave change switch gives me a peaceful plus sign. Should be 6 to the 39. This is a simplified answer, so we're good. Next one, again, I see a division, so I know I'm going to do subtraction, top minus bottom, negative 24 minus negative 9. Leave, change, switch, in this case gives me, again, a peaceful plus sign. But here I have different sign subtract. Take the sign of a larger number, it's going to be
X 15.
negative 15.
Oh, yeah.
But we can't leave a negative exponent,
X.
Sage.
Let's see.
Yeah, so 1 over x to the 15 because we take that negative 15 and we can flip it over the fraction bar to make it positive. Okay, key points for today. Leslie. Sorry, I can't hear her because lots of people are making extra noise. Go ahead. So what I hear her saying is before you expand, you must flip
Stop talking.
negative exponents over the fraction bar.
Got it, dude. Write it down. Write it.
Other key points. Perla. So the second key point she is telling me is just a reminder of basically the key points from yesterday. Remembering that if it's multiplication, that means that we add the exponents. If it's division, that means we subtract the exponents. If we're using rules. Okay? Any questions before we move forward? All right.